Occupied France, 1944. A lone sentry stands beneath a dim shielded lamp. Beyond him, wagons sit idle on the line, their silhouettes barely visible against the low sky. From the hedgerow, no warning is given. There is no crack of a rifle, no flash, no echo rolling down the track. The sentry simply folds, the lamp still burning beside him. For a moment, nothing changes at all. The rail yard does not react. Those nearby hear nothing more than a dull, indistinct thud. This was the kind of moment British planners had in mind when they authorized one of the strangest firearms of the war, a weapon designed not for battle, but for removal. Quietly, decisively, and without consequence. In this video, we will examine how and why Britain built a rifle capable of this kind of action, how it achieved near-total silence, what it demanded from the men who carried it, and why such a weapon existed only at the narrowest edge of the conflict. Its name? The Lisle Carbine. However, before this weapon could ever be fired in anger, the war had to present a problem that only silence itself could solve. The situation hinted at in that rail yard was not exceptional by 1944. It was increasingly common. As Allied forces prepared for the return to Western Europe, success depended not only on armies and air power, but on the removal of very specific obstacles: guards, sentries, signal operators, and isolated personnel whose absence could delay a response by minutes or hours. In covert warfare, those minutes mattered. The difficulty was that conventional weapons were fundamentally unsuited to this kind of work. Rifles were accurate and decisive, but impossibly loud. Even a single shot could carry across open ground, drawing attention far beyond the immediate area. Pistols were easier to conceal, but lacked precision and reliability at anything beyond point-blank range. Submachine guns, even when fitted with suppressors, still produced a distinctive report and mechanical clatter that could not be hidden in truly quiet environments. Suppressors themselves were only partial solutions. Most were designed as add-ons, devices screwed onto an existing weapon to tame muzzle blast. They did nothing to address the sonic crack of high-velocity bullets, nor the noise of automatic actions cycling under pressure. In controlled tests, these weapons were quieter. In the field, they were still unmistakable. British planners understood that the problem was not simply noise reduction, but noise elimination. To achieve that, the entire system, cartridge, barrel, action, and suppressor, would have to be designed together. This ran counter to standard military practice, which favored adaptability and mass issue over specialization. There was also the question of reliability. A covert weapon could not afford misfeeds or inconsistent performance. It would be carried infrequently, used rarely, and expected to function perfectly when required. Maintenance in the field would be minimal. Any solution that relied on delicate mechanisms or tight tolerances risked failure at the worst possible moment. By this stage of the war, Britain had the industrial capacity to build almost anything. What it lacked was a weapon that accepted severe limitations: short range, slow rate of fire, small production numbers, in exchange for one defining characteristic: silence so complete that its use might go unnoticed altogether. Solving that problem would require abandoning conventional thinking about firearms and accepting that this weapon would never belong on a battlefield. It would belong only in moments where nothing else could be allowed to happen. Once the requirement was accepted, true silence, not mitigation, the project moved into a space where normal military priorities no longer applied. This was not a weapon to be standardized, simplified, or produced in quantity. It was to be built around a single outcome, regardless of inconvenience. Development responsibility settled quietly within Britain's wartime engineering ecosystem, drawing on military oversight but relying heavily on civilian industrial skill. Much of the practical work took place at the Ford Motor Company plant at Dagenham, a facility better known for vehicles than firearms, but well suited to precision machining under strict secrecy. The environment mattered. This was a place accustomed to working from incomplete specifications, iterating quickly, and adapting tools to unfamiliar tasks. The designers began with a deliberate rejection of novelty. Rather than pursue experimental actions or exotic mechanisms, they chose the Lee Enfield bolt system as their foundation. It was strong, well understood, and mechanically quiet when operated by hand. This decision narrowed the problem immediately. The action would not define the weapon. Everything else would. Attention turned instead to ammunition and pressure management. The choice of a heavy, slow-moving cartridge was essential, but it introduced awkward constraints. The weapon could no longer rely on gas operation. Feeding geometry would be compromised. Ballistic performance would be limited by design. These were not problems to be solved away. They were accepted costs. Early prototypes revealed how unforgiving the concept was. Small changes in barrel length altered velocity enough to defeat the entire purpose. Gas venting had to occur at precisely the right point, or pressure would remain too high. Too much venting, and the bullet lost stability. Too little, and the sonic crack returned. Fouling accumulated rapidly, forcing revisions to internal volume and access for cleaning. The suppressor itself became the focus of constant adjustment. Engineers experimented with port spacing, chamber dimensions, and internal baffle arrangements, often without full documentation. Surviving examples suggest that the final configuration was not the product of theory alone, but of repeated firing, measurement, and correction. Silence was achieved empirically. Throughout development, there was no expectation that the weapon would ever be widely issued. That understanding freed the designers from compromises normally demanded by procurement. Ergonomics were secondary, weight was tolerated, appearance was irrelevant. What mattered was whether, when fired in a quiet place, the weapon would reveal itself. By late 1943, the answer was finally consistent. The prototypes no longer sounded like firearms at all. They sounded like nothing that could be immediately identified. Only then was the design ready to be acknowledged, not publicly, but formally, as a finished weapon. What emerged from that quiet, highly constrained development process was not a new class of weapon, but a deliberate inversion of existing ones. It was formally designated the Lisle Carbine, named not for a program or committee, but for the officer whose concept had guided its creation. In practical terms, it was a manually operated carbine built expressly for close-range covert use. It fired a heavy pistol cartridge rather than a rifle round, and it did so from a platform whose defining feature was neither accuracy nor rate of fire, but acoustic discretion. Every design choice served that end. The Lisle was never intended to replace anything already in service. It did not compete with standard rifles, submachine guns, or pistols. Instead, it occupied a narrow space between them, offering the precision of a shoulder-fired weapon with a sound signature closer to the background noise of a quiet night than to a gunshot. Its appearance reflected that singular purpose. The unusually large barrel was not a barrel at all in the conventional sense, but a housing for the suppression system that defined the weapon. The familiar bolt and stock were almost incidental, retained only because they allowed the device to be used reliably by trained hands without further explanation. Officially, the Lisle was simply a tool. Unofficially, it represented a shift in thinking, that a firearm could be engineered not around power or reach, but around absence, the absence of sound, reaction, and immediate consequence. To understand how such a contradiction was made practical, it is necessary to look beyond what the Lisle was meant to do and examine how it actually did it. The Lisle carbine functioned because its designers treated sound as a mechanical problem rather than an unavoidable byproduct. Every component existed to manage pressure, velocity, and vibration in a controlled sequence. At the center of the weapon was a shortened barrel, only a portion of which was rifled. Forward of the chamber, a series of precisely drilled gas ports allowed expanding propellant gases to escape almost immediately after ignition. This prevented pressure from building to the point where the bullet would accelerate beyond subsonic speed. Unlike conventional firearms, velocity was deliberately suppressed at the source rather than corrected after the fact. Surrounding the barrel was an oversized cylindrical tube forming the suppressor body. Inside, gases vented through the ports entered an expansion chamber of considerable volume, where they were allowed to slow and cool. Internal baffles, their exact number and geometry varying slightly between examples, disrupted gas flow further, breaking up pressure waves before they could exit the muzzle. Surviving weapons suggest that this internal arrangement was refined through trial rather than strict standardization, with practical results favored over uniformity. Crucially, The suppressor was integral. It could not be removed without tools, and it was never intended to be. This ensured perfect alignment between barrel and baffles, eliminating a common source of failure in detachable systems. It also meant that the weapon's weight and balance were fixed, an accepted compromise in exchange for consistency and safety. The action was manually operated. By avoiding gas or recoil cycling, the Lisle removed one of the loudest elements of firearm operation, the automatic movement of metal under pressure. After firing, the bolt remained closed until the user chose to cycle it, containing residual noise within the suppressor system. Even then, the smooth camming surfaces of the adapted Lee-Enfield action reduced mechanical sound to a minimum. Feeding was achieved through modified magazines originally intended for submachine gun use. This was mechanically inelegant but dependable. The heavy cartridge produced modest recoil, further reducing vibration and secondary noise. In use, the result was extraordinary. Contemporary assessments noted that the dominant sound was often not the discharge, but the impact of the projectile. In enclosed or rural environments, the shot could pass without immediate recognition as gunfire at all. These advantages came with costs. Fouling accumulated rapidly inside the suppressor, requiring careful cleaning. The weapon was heavy for its size, slow to reload, and limited in range. It demanded discipline from its user and attention from its armorer. But in return, it achieved something no standard weapon of the period could. It allowed force to be applied with almost no acoustic signature, and with that, it created possibilities that would soon be tested beyond the workshop. The weapon does not change the environment. It does not dominate it. Instead, it allows an action to occur without altering the behavior of anything beyond arm's length. A single sentry can be removed without alerting those only meters away. A task can proceed without triggering the chain of reactions that normally follows violence. But the silence places its own demands on the moment. There is no rapid follow-up, no second chance through volume of fire. If the first shot fails, the advantage collapses instantly. The operator must work closer than is comfortable, often within distances where failure would be immediately fatal. The Lisle therefore shifts risk rather than removing it. It trades noise for proximity, speed for certainty. Its user must understand exactly what the weapon will do, and just as importantly, what it will not. In this context, silence is not a luxury. It is a narrow corridor that must be walked carefully, because once the moment passes, the opportunity does not return. Whether that trade was worth making could only be answered after the weapon left controlled conditions behind and met the unpredictable reality of war itself. When the Lisle Carbine finally moved beyond development and controlled testing, it did so without ceremony. There were no public trials, no official fanfare, and no effort to integrate it into wider doctrine. Its distribution was limited, selective, and deliberately quiet, reflecting the nature of the work it was intended to support. Production numbers remained extremely small. Surviving records suggest only a few dozen, possibly slightly more, were completed during the war. This was not the result of failure, but of design intent. The weapon demanded skilled manufacture, careful fitting, and ongoing maintenance, all difficult to justify at scale for a tool that would be used rarely and only under specific conditions. Where it was issued, assessments were consistent. In terms of sound suppression, the Lisle performed exactly as intended. It exceeded the capabilities of suppressed pistols and submachine guns, particularly in rural or enclosed environments where echoes and reflections exposed lesser systems. Observers repeatedly noted that the report was difficult to identify as a gunshot at all, even at close range. Accuracy was acceptable within its narrow envelope. At short distances, the shoulder-fired format allowed deliberate placement that pistols could not reliably provide. The heavy projectile delivered sufficient terminal effect without relying on velocity, aligning with the weapon's purpose rather than contradicting it. Its weaknesses were equally clear. The weapon was heavy, unbalanced toward the front, and slow to operate. Fouling inside the suppressor accumulated quickly, requiring careful cleaning that could not be improvised in the field. Ammunition quality mattered more than usual. Inconsistent loads undermined the very principle the weapon depended upon. Perhaps most importantly, the war itself evolved. As Allied forces gained momentum, the need for isolated single-action removals diminished relative to larger, faster operations. Intelligence, air power, and mechanized advance increasingly shaped outcomes. The narrow corridor in which the Lisle was indispensable grew smaller with each passing month. After the war, the concept was not abandoned so much as absorbed. Later suppressed weapons benefited from improved materials, better manufacturing tolerances, and more flexible designs. Yet few ever matched the Lisle's singular commitment to silence as a primary engineering requirement. Today, the weapon survives mostly in collections and museums, studied less for what it achieved operationally than for what it demonstrated technically. It stands as a reminder that some problems are not solved by compromise, but by accepting severe limitations in pursuit of a single, uncompromising goal. That understanding brings us back to the moment where silence mattered more than anything else. In the rail yard, the lamp still burns. The wagons remain where they are. To anyone arriving later, the scene offers no explanation, no immediate sense that anything unusual has occurred. This is the true measure of the Lisle carbine, not the sound it made, but the absence it left behind, of alarm, of reaction, of escalation. It was a weapon designed to intervene briefly, then disappear into the background of events larger than itself. Britain did not build the Lisle to change the course of the war. It built it to solve a specific problem at a specific moment, when discretion outweighed force and restraint mattered more than speed. That moment passed, as it always does. What remains is an object that reflects a particular wartime mindset, disciplined, unspectacular, and precise. A reminder that ingenuity is not always loud, and that some of the most carefully engineered tools in history were meant never to be noticed at all. The Lisle carbine did its work in silence, and history, fittingly, barely heard it.